Welcome back to my channel. In this video we shall be solving the final question from Math 126. It's been a long way, but finally we are concluding the paper 2024-2025 academic year paper. Okay, so let's dive in. The question is, show that y0 12 xy, so the determinant of this matrix, so the determinant, so let me name the matrix as let A be equal to matrix y x y 0 then 0 1 1. So we've been told that we've been asked to show that the determinant of A is equal to 0 is an equation of a parabola. So this is what we are asked to show, the first part, and then B for the parabola in A. So after dealing with it, we should find the coordinates of its vertex, focus, and endpoints of the Latus rectum. So we are going to find the coordinates of the vertex, focus, the endpoints of the Latus rectum. Also find the equation of the Directrix and the length of the Latus rectum. So we have a lot of work to do. Let's dive in, let's solve that part, and afterwards we sketch the parabola, then find the equations of the tangent and normal. The question is loaded, the final question is loaded, but with patience we will have the answers to all questions we've been asked. Let's look at the first part. We are going to show that y0, so so now we name the matrix as A. So the determinant of A is what? Is a parabola. Y0 0 1 1 is equal to 0. This implies that, so since this is the determinant, whenever you see these symbols in matrices, it means that you are dealing with the determinant. But if you see the square bracket, that's the matrix, or if you see the braces enclosing the entries, it means it is a matrix. So this is used to represent matrices, to enclose matrices. But if you see these straight bars, they are used to enclose the determinant, to tell you that this is a single number, but not a matrix of different points. Okay, so here, how do we find the determinant? We can use this rule. We can use this rule. So if I take if I take y, I will delete this row, this column, and delete its row. So the remaining rows, the remaining matrices, I'll multiply it by what is determinant, y0 and 1 1. So I'll do same to the 0. So they are all in the same row, but the column will be changing. So this time around we are deleting the second column, so leaving so minus 0 multiplying the determinant of x0, and then 0 1. plus 12 multiplying 12 multiplying, so this time around we are deleting the third column. So 12 will now multiply xy 0 1, and this is equal to 0. So why do we have plus minus plus? This goes back to the cofactors of the matrix A. So if I take this entry is known as the entry, let's use small a. So if it was small a, so A11, so A11, this will be A12, A13. The first one represents the row, so row 1 column 1, and the second one represents the column. So A11 means that the first entry of row 1, so the entry of row 1 column 1, entry of what? Row 1 column 2, row 1 column 3. So to determine what, so to determine the cofactors, we will say that the cofactor of this entry of the A1, the cofactor of the A1 will be we will take -1 to the power I plus j, where I is the row and j is the column, multiplied by what? Multiplied by this A11. And what is the minor of the A11? You obtain the minor by what? Deleting the row of A11. So as we delete this row, the entire row, and we delete the column of A11. So what is left is what? What is left is this portion, which is what? Y011. So that's how can we obtain this. So ij, so here our I is 1 and our j is also 1. So 1 plus 1 gives you 2. -1 to the power 2 gives you what? Give you +1, and that is why that part is what? Positive. So you see that we have a positive value here. And the same thing if you pick the second part, if you pick the second one here, it's 1 2, so you see that it will change to what? To 1 plus 2 is 3, -1 to the power 3 is negative, so you see that the 0 is what? Negated. So that's how the cofactors work. So from the cofactors we move to what? Finding the determinant. The cofactors, with your cofactors you can now find what? The determinant by multiplying what? The entry by is what? Cofactor. The entry by is what? Cofactor. So y multiplying the cofactor, which is just the positive part of what? Y011, and then -0 this. Oh, you can find what? You can find the determinant of this. So we won't waste time on it. We have a lot to cover. Maybe if we want, we can record another video. If you want an explanation of why we just put negative here, you can why we have negative here and the rest are what? Positives. If you want the explanation, you can leave your comment in this, you can leave the comment in the comment section, so that if we need to record another video for only that, to explain that particular part, we will do so. But we have a lot to cover now in this video. Y multiplying, So the determinant of this 2 by 2 matrix, y times 1 is y, 1 times 0 is 0, so it would have been y plus 0, so sorry, y minus 0, and it's still y. So minus 0 multiplying anything is just 0, so okay, let me write the 0, plus 12 multiplying 1 times x, which is x, minus 0 times y, which is also 0, so I don't need to write it, it's equal to 0. So you have y squared minus 0, don't need the 0, plus 12x is equal to 0. This means that y squared is equal to what? Negative 12x. And this is what? A parabola. This is the parabola of the form, let's say y squared is equal to negative 4ax, or you can equally say that it's of the form y squared is equal to 4ax, right? So we can have it this way. So we've seen that this is what? A parabola. And the first part of the question was asking us to determine or to show that this represents a parabola, and we have seen that the determinant of the matrix A is actually a parabola. So let's see what we will be calculating next. For the meantime, so the question, okay, so the first part, we are done with this. The first part showed that this determinant is an what? Is an equation of a parabola, and we've seen that it's an equation of a parabola. For the parabola, now we have the parabola. So for that parabola in A, find the coordinates of each vertex, focus, and end points. Sketch the parabola. So now let's find what we are asked to find in B. So let me for the meantime, let me cancel this. So let me write V for the vertex. So we need the V, the vertex. It's a point. Focus. So we need the focus, which is A, 0. The endpoints of the directrix, the endpoints of the Latus rectum, So let's say L bracket open. So you search that you have A, 2A, A, minus 2A, and then let's say I-fin. We also need the equation of the directrix, so D, and then V. We need the length of the Latus rectum. Okay, so now let's work on this part. So we have our equation y squared is equal to minus 12x. So by comparing this equation to the general form, which is y squared is equal to 4ax, we see that by comparison 4a is equal to negative 12, so our a is equal to minus 3. So this is our a. Okay, first let's talk about the vertex. So the vertex is what? The point, the origin 0, 0, because the standard form of a parabola is y minus k to the power 2 square all square is equal to 4a bracket upon y minus h square. So here's the case. Our k is what? 0. H is also 0. That's why we have y square. You can see that we can't see any h or any k. It means that they are 0, 0. So our vertex is what? 0. The point 0, 0, the origin. Okay. So for our focus, the focus is the point A0, where A is this value from what? The general or the standard form. After comparing the standard form to what? To the equation we have, or to the parabola we have, we see that our A is -3, so the focus will be what? -3, 0. So our focus is now -3, 0, and with this we can find the Latus rectum. The Latus rectum will be what? The Latus rectum will be L, such that we have -3, what? 2a, which is what? 6, -6, and the point -3, -2 times -3, which will be what? +6, which will be +6. So we have this. Then we are finding the directrix. The directrix is what? Perpendicular to what? Is perpendicular to the Latus rectum. Is parallel to the Latus rectum, and it is perpendicular to the axis of symmetry of the parabola. So, and we know that the Latus rectum passes through what? It passes through the focus. You can see the -3, -3, -3. So for the directrix, we have x. So it's such that x plus our a is equal to 0, and here our a is what? -3. So x plus -3, that means x minus 3 is equal to 0, which means that our x is equal to 3. So the line x is equal to 3 is what? Our directrix. So our directrix is such that x is what? So this is the line x is equal to 3. I'll just make up space for that. So x equal to 3. And then which one again? The length of the Latus rectum. So L is equal to, so the length of the Latus rectum is equal to, so the root of, so we should have what? The x coordinate x1 minus x2, or x2 minus x1 square plus y2 minus y1 square. Here, in our case, our x2 is -3, x1 is also -3, so we have root of -3 minus 3 minus -3, which is now +3 square, plus y, which is +6, minus -6, which is +6 square. This is equal to root of what? This -3 plus 3 is 0, 0 square is 0, plus 12 square. So 12 square, this will deal with it. Even our what? Length of what? The Latus rectum is equal to what? 12 units. So we have everything now, 12 units. So now let me make up space. I think we are done with the B part. So we're going to carve out some space so that we can now sketch. We can now sketch the parabola. So let me see. We are done with it. We have found everything. we've done everything we've been asked to do. So now let's look at the C part. We are sketching the parabola, so let's sketch the parabola. Now we are sketching the parabola. Let's have our graph. Now, since the parabola is y squared is equal to 12x, negative 12x, it means it will open to this side. It will open to this side, to the left of what? The x-axis. So let's have this, let's say 2. Now I just use my 1, 2, 3. 1, 2, 3, but then I have 2, 4, 6. 2, 4, negative 6, negative 0. 1, 2, 3, 4, 4, negative. So for our directrix, we have our directrix here is this line. So just this line, this is our directrix. Straight line. So this line x is equal to 3, and for our focus is here, which is negative 3, 0, and then our latus rectum, one point is here, negative 3, 6 is here, and then the other point, negative 3, positive 6, negative 3, negative 6 is here, negative 3, positive 6 is also here. So we have it like this, so this is our parabola. So we should pass through the latus rectum. The latus rectum is on the parabola, but you can see that the focus is not on the parabola. So this is the parabola we've been asked to sketch. So this point is negative 3, 6. This point is negative 3, negative 6. And this is the parabola. Okay, so we've done the C part. Now let's check what is remaining, what is left for us to do. So let's check. I'll close it now. So we are left with the final part, which is D. Find the equations of the tangent and the normal lines to the parabola at the point negative 3, 6. So I'll just delete everything. If you want all that we've done now, you can replay, or you can just go back and then check what we've done so far. But for now, I'll delete everything and we'll concentrate on the final part of the question, which is D. So we've been given the point, let's say P, negative 3, 6. We are going to find the tangent equation and the normal equation. Okay, so let me open the notebook once again. So let's say we know that our equation will be in the form y minus y1 is equal to m bracket. So let me use empty so that it will be the gradient of what the tangent of multiplying x minus x1. But let's go back to this one, to y minus y1 is equal to mt, so mn normal x minus x1. Okay, so but our our parabola is y squared is equal to minus 12x. Let's find the gradient. We can easily do what? We can differentiate this to find the gradient. If we differentiate this implicitly, so the implicit differentiation will give us 2y dy dx. So the dy dx is our what? Gradient is equal to what? Minus 12. So this means that dy dx is equal to what? Minus 6 over y. If we divide both sides by 2y, if we divide here by 2y, divide here by what? 2y, we have negative 6 over y. So this is our dy dx. So for mt, that is the gradient for the tangent, we have what? Negative 6 over y. So the gradient of the parabola is the same as the gradient of the tangent to the parabola. So this means that at the point at p negative 3 6, our gradient for the tangent will be equal to what? Negative 6 divided by the y coordinate, which is 6. You know, it's negative 6 over y. So the y coordinate is 6. It's now what? Negative 6 divided by 6, which is what? Negative 1. So the tangent, the line of the tangent will now be the y minus our y1 is 6, so minus 6 is equal to our mt, which is what? Negative 1 multiplying x minus x1, which is what? Negative 3. So it's just minus negative 3, so it's now plus 3. So we have y minus 6 is equal to negative x minus 3. So let me bring, so this means that we have y, I'm bringing the x here, plus x is equal to what? Negative 3 plus 6, which is what? Positive 3. So this is what? The equation of what? The tangent. Okay, so for the normal we know that mt times mn should be equal to what? Positive, should be equal to negative 1, because they are what? Perpendicular. The tangent is perpendicular to the normal. So if mt is equal to negative 1, then n will be equal to 1. So our y minus 6, y minus y1 is equal to mn. So mn will be equal to positive 1. So mn is positive 1 multiplying x minus negative 3, which is plus 3. This means that half y minus 6 is equal to x plus 3. And I'm bringing this guy here, taking the negative 6 there. This means that we have y minus x is equal to what? 3 plus 6, which is 9. And this is the what? Equation for the what? Normal to the parabola, the line which is normal to the parabola. Y squared is equal to negative 12x. And we are done solving the final question to the paper. So we are done with the paper. We've answered all questions. Maybe if you see any mistake from all the videos we've made, you can correct me, you can let me know a mistake, or if you just want to advise me on certain things, your advices are highly welcome. But for now, this is what I can offer. If you find my videos, or if you find the content helpful, please do subscribe to the channel. And I'm just done with everything, so thank you very much for your time. If anything, we will meet hopefully in the next video, where we will start a journey to answering other past questions again. See you in the next video.